Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And this week we're kind of hopping out of the rabbit hole that is knowledge gaps. I think we beat that dead horse pretty good. And, if you didn't hear it, we got Ed back with us this week, Yeah. So, he's no longer doing his own thing. So, welcome him back to the grind. This week we're going to talk about, incorporating Industry 4.0 into 3D printers. We did a snack episode at the beginning of this podcast run of Industry 4.0, and we will do a full episode on Industry 4.0 only at a later date. So that is coming. We will do a video on it as well because we find it interesting. And I do want to throw this back out there again, just like I said last week. Thank you everybody who's listening to us. We're going to reiterate that at the start of the podcast because y'all are really getting in on it. So, when we start thinking Industry 4.0, I don't know about y'all, but I'm thinking, MQTT, the Octoprint stuff and pushing it to like a Kibana log and going from there. What are y'all thinking?
Yeah, from my point of view, that's exactly what I'm thinking, Nick. Also, we're talking about like unified namespaces where we take different systems and they populate data or pull data from this unified namespace. And what that does, that reduces the cost. And what it does for you is that gives you the ability to understand what's happening with your equipment, like predictability, how productive am I? When should I do maintenance and those type of things? So all those things can be used in Industry 4.0.
Yeah. I mean, it's exactly the Octoprint, the MQTT interface. Like that's exactly where I would go with thinking about Industry 4.0 with 3D printing. But if it's one instance of Octoprint, I'd say that's small scale, and then we're trying to push to industry like a bigger, like let's say print farm. There's Octofarm, which is several instances of Octopi you can tie together. Now, depending on what you run it on, because realistically, personally, I have it running on my Octopi and a Raspberry Pi. It's a 3B plus, and it's existing on its own, but you could do a stack of Raspberry Pis running several printers. You could do, depending on how much RAM you got on one, if you get one of the newer ones, you can run multiple on one.
Doing Kubernetes clusters.
Create some. You can even create some partitions and things like that if you really want to. But honestly, you don't need to. But that to me would be. We're talking getting into the industrialization. We're bringing in more and more and more data. So being more robust, I think, would be the direction I would go in, because in my experience, I'm on a small scale and I don't necessarily have storage space issues, but my Raspberry Pi crashes quite a bit, and I'm not even pushing it too hard. And so that's where I would go as far as that. Maybe even thinking if I get a small form factor like a mini PC, and create a Linux environment there that runs Octopi,
and if you think about it, you can use the Industry 4.0 principles, inside the home. It's pretty much what that does. It bumps you back to IoT with it, which is still inside of the Industry 4.0 namespace, which you talk about IIOT, and at that point, if you think about it, if you're printing something on a 3D printer for profit. You're an industry.
Yeah.
You're inside industry at that point. You know, you've crossed over from being a hobbyist to an industry professional.
That's fair.
You know, so you know you can easily play with that. You know, and it's as easy as setting up a Raspberry Pi stack, a cluster, and doing Kubernetes deployments, where you have it set up where it's a Octoprint, Octofarm, or something like that hooked up to your. Because most people have 2 or 3 printers in their house, anyways.
Yeah.
You know, it's just how it goes. Once you buy one, it's like Pringles.
Well, they do different things too.
Right, but it's like, you know, it's like Pringles. You know, once you pop, you just can't stop. You know, and just how it goes. So you have all of them hooked up together, hooked up to the, you know, going through Octoprint, Octofarm with a port to an MQTT server. It talks over that. It's got your unified namespace there that it immediately sends that via a Kafka instance or just a direct drive Logstash instance right to Kibana, you know, which is Elasticsearch.
Yeah, and you connect to your cloud now.
And the thing is exactly, you can, you know, if you have your own cloud, you can set up a, you know, a Kafka instance or an MQTT instance and a, Kibana instance. However, all of that is free, so it doesn't cost you very much to play with it. You know, it's once you start commercializing it is when you start having issues.
So I'm going to be devil's advocate as always.
Debbie Downer.
Yeah.
I'm just kidding.
and maybe, but maybe not. Here's the thing. What is essentially the essence of a 3D printer? It's the inputs and the outputs, right?
Right, exactly.
Yeah.
So Raspberry also makes a Pico.
Yeah.
Now the Pico has the capability to be wireless.
Yeah.
With that, now I do not have to actually leverage maybe a Raspberry Pi directly as a stack. I can use it as a
jump box,
a tunnel, and from there are a lot of web-based applications, or we can make some type of SaaS in the cloud, and you make it cloud-based, or AWS even so.
Yeah.
And we use AWS to do some of those things, and then if your company's profitable enough and you make a company, you're doing 3D printing, then that's an avenue you can use with AWS, because now I can take one instance of a Raspberry Pi and then take a Pico W, and I can interface with those wirelessly with MQTT. And you know, like you said, we use the stack to do the rest of the stuff in the unified namespace.
Which is even nicer with the Pico Ws is the fact that, you know, I can take a Pico W and I could take a Raspberry Pi or a server for that matter, and I can run on that Raspberry Pi a onboard router. So it creates its own internal Wi-Fi intranet between the 3D printer and the Raspberry Pi. So now you set up your own intranet where it's a secured offline intranet that they're communicating back and forth in a over-the-air, you know, per se, network. So now if I drop an STL on Octoprint on one thing, it's going to wirelessly send it to the printer without actually having to even touch it at that point. So, you know, and then you can take that and bounce that to wherever it's going. But everything's going to be communicating over that pipe. It's a 2.4 gigahertz, you know, or 5 gigahertz band, depending on what you have on board. You know, but the thing is you're talking only micromillimeters of data. You're not talking heavy data. And if you do it, you know, with that route, the internal router network, you got some power behind you. Right. So, you know, you're playing with some things. Each one's got its own router. They all talk back to each other, and then they all have their own namespace, going back to the like the Mosquito MQ or something like that, and then going back into a Kafka instance or back into, you know, whatever instance you want, you know, and that ties to, like, you know, a messaging of some sort,
right,
you know, back to the individual. Oh, cool, look, my print's done. Or I've ran, you know, if you really want to get down to the nitty gritty of it, I can count how many prints I did. So I know on that one hot end or that one nozzle, I did 25 or 26 prints before that nozzle needed to be replaced.
And then we can leverage stuff like TinyML and Tensor.
Yeah.
And now you can start using machine language and some AI along with all these things. Yeah. And now not only does it become powerful to know, hey, how long did it take to do that?
Yep.
What went wrong in the print?
Right.
See, that's the point.
And the thing is with that, it's already wrapped into Kibana as well. It's already there.
Yeah, you get your no, you're fine. You get your error logging with Kibana. I was gonna mention those things anyways, because the whole point of that is for you to leverage that data to understand where your pitfalls are. What is my bottleneck in my process? Because at this point we're not necessarily worried about quality, but it's going to get to that point when you have enough data. Like, you're going to be able to fine tune those little issues that you're having, and honestly, you could probably diagnose the problem with your prints with that data. So if the printer is like saying, "Hey, it's taking extra time to finish this print. You've done this historically 20, 30, 40, 50 times, and this one is now an hour over or 30 minutes over its time. You should check it out." Or critical failure, we've stopped before the print's time done, or I've got a report back, or a sensor failed, and I have to pause the print. But then also remembering that this is how long it takes. So if this is where I stopped at my print, you got your critical failure recovery, and you can restart where you left off.
Yep.
So like that saves filament, that logs and creates efficiency and drives towards upgrades and everything.
Right, and the thing is Ed, you know as well as I do, from the maintenance standpoint and stuff like that, the area that we play in, the area where we're trying to get John into, we're talking about taking these 3D printers and adding linear rail. We're already talking about using stepper motors. However, if we go to a stepper motor plus linear rail, we've gone now to an OT environment. We've left just the basic environment. We're now moved over to an OT environment. So the thing is what's actually stopping somebody from replacing the current the current motherboard that's on there right now, and replacing it with a PLC of some sort, and running a 3D printer off of a PLC, and all it has to do is have a backhaul on it to send the STL via telegram or some sort of TCP/IP communication back to the machine.
It's not an issue because it can be done.
Yeah.
But then you have to look at viability for, is it something that's necessary? Because basically a PLC has a microcontroller also.
Right.
It's running the same thing as, it's similar to what you're doing with a Nano.
Right.
So if I had a farm, then it makes sense for me to maybe use that in a farm environment, but here, let's imagine this.
But the thing is now, I think I know where you're going with this, and see if I'm going down. See if I'm falling down the right track here, because the thing is, like you said, if we had a farm of these things, we'd have an HMI, and then we'd have it pointing to each one of the PLCs on the shop floor or on the farm itself.
Each of your 3D printers would be at this HMI, or
you'd set up a localized HMI.
Yeah.
Like a cell.
Yeah.
And then it's cool if I know this printer is only going to print X. This printer's only going to execute Y. I would send that command from that HMI and say, okay, cool, execute X.
Yeah, or from your phone.
Yeah, or from your phone if you do.
The HMI could be your phone.
Right.
Yeah.
Like we talked about that. We've talked about that before.
Yeah.
And then actually in the Industry 4.0 snack that we did, and also the digitization that we did, because we're taking things that we've done in the past and roll them out to something that's now a little bit more mechanical. However, we're trying to take something that is a 1980s, early 90s design, and trying to bring it into the new age. You already got people who are using their machines Utimaker actually, to read the filament that you put inside the machine and automatically auto-calculate your prints.
Yeah. So that's the thing here's the thing I was saying when I say imagine. So I'll address what you said first, and then I'll explain what I mean by imagine. So what I mean is you're doing batch processing. So basically, say if I'm in a paint department, I batch process in a mix room, and this I have auto control valves that are open and closed based on which color. Only the color I need, cut off every color. So say if I had a print farm that had multiple hot ends and multiple extruders, and I wanted to run multiple filaments because I wanted to do maybe some different things with the print, like multicolor, multi-textured, whatever it is. Then you can do this by saying, hey, disable this one, only this one can run. So you could do that. So that's the nice thing with using a PLC, because it's good for batch control. Yeah. And I don't have to have a big, I don't have to put a bunch of Raspberry Pis together. I don't have to do a whole bunch of things with like bringing multiple PCs and servers and so forth. I can do all that with one PLC and one server. Yeah. Or one PLC and the cloud. But here's the thing I would like to challenge everybody on is to think about. If I was able to take all of the data from all of the printers, because Industry 4.0 is not about connecting everything to everything. It's about data. Yeah, exactly. Data is the thing that's the power.
Data is the new oil.
What if I'm able to take all of the data from every STL file that I got from somewhere else and was able to get all that data populated to the cloud, and from the cloud I could say, hey, well, everybody had this problem with this STL file. Well, there's something wrong with the supports. Mm-hmm. This could be identified quicker. I don't have to spend hours, because I don't know if you've ever done a print for 24 hours and you're like, oh my God, everything's perfect, but...
Oh, yeah. I've got some that's been 6 hours, and I was like, I got to pull the plug, I got to stop it, and it's happened several times. So, it's...
First few prints I did on mine.
Yeah, it's definitely, and it's like half the spool, and I'm like, oh, great. I done wasted my whole spool. Now that's my resource. I don't have a way to recycle it or reuse. I kind of want to take another jump, unless you had something to add. When I think Industry 4.0 and 3D printing, this is something that I've been kind of playing around with for a while, and it's automation. You talk about the PLC, and it kind of like you talk about it controlling these things. We're talking about sending the files, saving the data, controlling the data, using it to kind of make an educated decision on what I should replace, when I should replace, to maintain, as much uptime as possible. But I've been thinking and trying to work towards how to automate this process for not even just the like the IT side, like the OT's, the actual like physical, like how if I am away from my print farm and a print finishes, what am I to do to make sure the next one comes through? Now there's a couple schools of thought. There's a way that you can adjust the G code so that you can use your hot end to knock your print off the bed as a plow, could possibly damage it. It's an option. Honestly, people do it all the time. There's a printer that's probably worth $1,200.
You're talking about the continuous mat?
It's got like a tread, like a was it like a treadmill? I think about like it just continues.
$1,300.
Yeah. But it allows.
It's cool as anything, though. I'll tell you that.
But you plug that in and you connect those things we've been talking about, and you give this the ability to continuously print. Not only do you create an autonomous environment that you don't have to be there the whole time, you can create a maintenance window of where you can be like, okay, this is the time that I can do that, and you could more accurately predict those maintenance windows with. All that information that you're gathering with sensor, if you put any sensors or anything like that with it.
Or we could print a 3D robotic arm, and the robotic arm can pull the things off the...
Yeah. Okay, so that's actually... I'm closer to that than anything else. just because building a robot arm is cool in and of itself. Like, if the robot arm just dances or waves, I will measure it as a success. Before. Yeah, just have it. Like, I built... a Kuka robot in my living room, and it's just like all it is opening the fridge, gets me a beer, closes the fridge. That'd be cool.
That'd be useful.
That would be something that somebody would probably buy immediately.
A 3D printer is as close to building a robot from a standard point of view. Yeah, it's the same concept. Instead of using stepper motors, you're using servos.
Yeah. So that's the thing. Now there's a fantastic model out there. So if you ever see the Thor on Thingiverse. That's what I'm going to try to make.
Yeah, there's a bunch of them out there.
Yeah, and it remove the print bed and place a new print bed. I don't got to worry about damaging my print by using a plow. You set it over here. There's a cooling rack, and it'll honestly, if you're using PEI spring steel, when it cools, it'll pop right off. If you try to remove it before it cools, you will bend it, bow it. You'll do more damage than anything else. So,
especially if you're using non-adjustable beds.
Yes.
If you're just using a solid bow, you pick one up and as a magnet, you set it back down, it locks into place, you're done.
Yeah. Yep.
Re-level, off you go.
Yeah, because it doesn't change, and especially even more so if you're using Core XY, because now it's not moving in the Y direction, like back and forth, and it's easier for that robot arm to predict where that bed's gonna be at. So.
Yeah, that or you put vision on it.
Oh yeah, you put some
computer vision. You put computer vision on it, and computer vision will take care of the rest.
Yeah. Now we're talking like we're in the year 3000, but yes.
Well, the thing is honestly, we use computer vision now.
Yeah.
So computer vision is not new.
Well, yeah.
It hasn't been new for a while.
Yeah. Like he's talking about, they use pick and place robots, and it's Kuka has one, Fanuc has one, ABB has one, and basically they're pick and placing they're making.
They use Hershey and kick they get the Hershey's
and they're also baking like cakes and these little cakes you put in the package, and the robot just pick them up.
Same thing with
same thing with peels. They do the same thing.
Stuff like that. If you think about it, you can put computer vision on a 3D printer, and it'll actually tell you if you have spooling. If you have if you have netting.
So
that's computer vision.
Was that we were looking at that the other day with the spaghetti detector?
Spaghetti detector. That is computer vision.
Fantastic, actually.
That is a computer vision, machine vision, I should say, way of looking at it. And you can put that on a robot, and that robot can pick exactly what's going on out of what's going on, as long as it's programmed to tiny NML now, or there's even other programs that control it outside that box.
Yeah,
and you know me, I got to go Star Wars. Can't go an episode without Ed going Star Wars.
I'm a Star Trekkie, so
the real
tech.
But anyway, we buy cartridges to put in 3D in printers, right?
Yeah.
Why are we not putting intelligence in the spool?
To let us know when.
Why does the spool does not have intelligence where it can give feedback? Why do we not make the spool itself intelligent?
And you know what?
There's no way to deal with those spools out there that you have to replace, and those things don't work well.
You know what?
But you have to replace it anyway when it's
the ones that clamp on and off as you replace the filament, usually by a filament replacement.
Not clamp on and off. I'm saying you take that same concept there, and you embed electronics into that same concept. Using Wi-Fi, Wi-Fi, as the Europeans like to say, or Wi-Fi. Basically, you can do or Bluetooth. We can do all that Bluetooth through a sensor that communicates directly with this.
Yeah.
And with vision. All that the camera can also be wireless.
Yeah, makes sense.
And they all communicate. It's a communication via Industry 4.0.
Yep.
And they all populate data, so we can know when we use 3D Solitech, if it's a problem with it, it goes straight to the cloud.
Yeah.
And they get that information so that they can respond now to fix the problem or identify when that problem occurred in their plant.
Yeah, that would help out everybody at that point.
Nip the problem in the nip the resource problem in the butt, and then also like we talked about it before, and how do you get your quality better, and like we've had it on several fronts, but like that is a clear-cut way for you not to even have to do as much work to have your quality improve. So to me, it's a no-brainer. It should already be getting made, and that's why we were looking at, what was the bamboo? Mm-hmm. Like that one, using LiDAR, that's completely game-changing.
That's another Industry 4.0 mentality. Usually, anything you see, right now, everything you see coming out of Germany, as far as printer-wise and stuff like that, is going to have some version of Industry 4.0 on it, because it is now a manufacturing standard coming out of Berlin. And one of those things is like, what we looked at today, I don't know if you've seen it, the Kodak printer. Mm-hmm. Kodak, yes, the film company, they do make their own filament, and they make their own printer.
Yep.
Yeah, it's about time they got on board. Kodak invented the daggone digital camera.
Yeah.
Really?
And the thing is you got HP already involved in that. Stuff like that. So HP LaserJet, literally, now is a laser jet that can turn a sheet of paper into an object.
Right. Yeah. Well, actually, how many times that you guys used a printer, a consumer printer, and had to say, well, hey, the paper jammed up. It jammed up because of a reason, right? Like dust or something. Yeah. Or you didn't feed the paper in right. Yeah. And the repeatability of that printer is astronomical.
Yeah.
These machines that we're using in the hobbyist industry, that we want to put them in commercial and industrial industry, should have repeatability as or even greater far superior than just a 2-dimensional print.
Yeah. And the thing is, working in IT, you see the weirder when it comes down to printers. The best excuses when it comes down to printers. It's like, the one thing you like to say about printers is, you just can't fix the human error.
No.
And sometimes that includes the human being who thinks that they can put paper in a printer without unwrapping it first.
Now, you know what? Overloading it too. There was a thing that existed. It was called the Darwin Awards. Yeah. There should be an award for when something in IT happens that we give to that individual.
Oh, yeah. Oh, man. And y'all, by the way, don't ever think that your monitors are powered via VGA cable. No, don't do that either.
I guess my power through the cloud, right?
Right, exactly. Get to Wi-Fi. We've now figured out a way to make a Tesla coil not fry somebody. Cancer is not a thing.
Like you get that call, you're like, no, hold on now. You said what? Yeah. You figured this out? Because we should really talk, because I need to patent that and we're going to make some money.
we have had customers tell us that on multiple occasions that I thought my laptop charged via Wi-Fi.
Which, maybe, that exists somewhere in the 29th century.
That, and we've also got, hey, guess what? It doesn't charge off of PoE. We've gotten that before. If you got that much power, come over to a switch, call us. Believe me, we're interested.
Yeah, curious.
Yeah, mostly curious.
Why is it not on fire?
Yeah, but the thing is, it's like, that leads me back, speaking about PoE and stuff like that, that leads me back to the printers. Why in the world, and this is going back to the Industry 4.0, everything should be wirelessly connected or connected. Why do we buy printers now that don't have an RJ45 port on them, where I can actually put them on my network, and I can get to them from wherever I'm at, and I don't have to worry about running on Raspberry Pi Octoprint, or even Octoprint at that matter. I can build an application that handles it all for me.
Yeah, so just nip the middleman out,
and
exactly. have the actual.
That's
CPU on there.
That's possible via, like I said, the Pico.
Yeah.
And the reason I say the Pico, because the Pico is at a price point less than $6.
Mm-hmm. Yeah.
And what that means is now I can take the Pico and take a module that's Ethernet capable, or if I want both, if I want RJ45 capability, and I also want wireless, I can have both. Like most PCs.
Yeah.
Yeah. Yeah, I think getting it to be wirelessly connected is something that's like important. One thing that I've had issues with my Octoprint and my Raspberry Pi is that the cable, the USB micro or USB-C cable is like, it's either disconnected or it has a serial, quote unquote, serial mismatch where I need to restart everything again.
Yeah.
And that's kind of frustrating because you have to do it, and then if it comes back the next time, it's doing it again. So it's been frustrating with that, and I would rather it be wireless.
Yeah.
Well, I wonder this.
Or just RJ45 connected. So
if it's RJ45 connected, that's better. But having it to connect to the printer via a USB cable, those.
Well, I wonder this.
Yeah, I'd rather get rid of that.
You've got a C. We've got that USB-C, right?
Yeah.
Why can we not put a USB-C adapter for Ethernet?
They have them.
But no, I feel like that would be getting closer to
like a docking station.
Getting to power over Ethernet, honestly, or a docking station. Yeah, because like that would be the whole purpose for me. Like we're honestly creating with the Octoprint, creating a docking station for it. Yeah. For lack of a better term.
Yeah, like I said, for me, like I said, and the thing I like the Octoprint and I like the Pico in general, but the Pico started out being like less than $50, and then all of a sudden it skyrocketed to over $100, and it is hard to get. I'm just curious that why are we not leveraging more things like the Nano or the Pico itself, because with that the price point is like less than $10.
Yeah.
Less than $10, I can get into it and do any communication I want to do.
Yeah.
It has every type of communication you want to do built into it already. You can do those things over that. You just have to do the programming with a little bit of whatever language you want to use, C, C++, Python. I mean, that MicroPython. I mean, they're using all type of languages now. I mean, it's It's endless what you can do.
And also now with the new motherboards that are going to be that you can install in these 3D printers, mostly from Big Tree. They have the big ones now, the big size ones, and they do have a serial port.
Okay.
So you can actually get them with a serial port. They're a little bigger. They won't fit in the Ender 3s. They'll fit in like the Ender 5 Pros and stuff like that, and all the other ones. They may fit. You might have to do a little. You might have to do a lot of modification.
Yeah, you might have to build.
But it will fit.
Case.
That or you can just offload it at that point.
Which I have some ideas about that. About what can fit and can't fit. What if what if the electronics lived in a stand just like we use on our PCs when we take a PCs and sit it on top of a stand?
Yeah.
Yeah.
And then even if we made it like a docking station and we built a docking station on the bottom of this printer and the printer docked onto the damn controls.
Yeah.
Yeah, that makes sense. And then you just plug and play at that point.
Yeah.
Yeah. That'd work. That'd definitely be one way of doing it.
No, I think that makes sense. And honestly, whenever getting to a place of a quote unquote farm, there needs to be a centralized workstation, so some type of computer so you can slice your files as well, maybe work on some of them if there's any issues you see. But then that would be something that I would want, is that all of them are connecting wirelessly.
And it's like, if you think about it, and I know we're getting ready to go over our 30-minute window here, but which it happens. We also like the fact that if you think about it, if you talk about like research and design, with 3D printers and stuff like that, you're doing a little bit of R&D, for the 3D printers, for stuff that's coming online and stuff like that. Being able to monitor all that from a distance, be able to collect all that data. That's the main reason why we bring this up. So that's the best part is getting your data so you can make adequate decisions and build what you want to build. To support the hobby or support the people who are moving forward. Outside the hobby generation.
Right.
Who knows? Who knows what you may find from us later. But, it's here nor there. We'll figure that out.
Definitely some problems I think we can solve.
Yeah. Either solve or create. Definitely we'll definitely ruffle some feathers. And that's the goal in all of it.
Security. I make a problem. I solve the problem. I got a job.
Yeah, right. But the thing is, if we ruffle feathers with big corporate, then sure, why not? Let's have some fun. And the thing is, there's people out there, that want to, join in on that, feather ruffling. We're more than happy to talk to you. Maybe we can join forces and play around a little bit and, see what we got, have good conversations and go from there. Maybe get you on, with us talking. I don't care where you are at in the world, we can figure something out. And mind you, remember that most of us barely have I guess you could say understanding of the native English language. So let's just keep it to that.
Oh, I try.
Yeah, I try too. I got Southern English down better than I got regular English. So
wait till you get that Geechee.
It's got Alabama in, down pat. So we'll go from there.
So the one thing I want to say is that what made this country great was guys that entrepreneured and did things in their garages. And that's how we came up with a lot of the systems we got. Mainly that's how
HP,
Apple was
Amazon.
Matter of fact,
Amazon napkin.
Maybe some of you people are gamers, and play retro games. There are guys that do retro gaming with garage, gaming. So don't be afraid to get out there on your own and design things. Don't worry about, hey, well, maybe I'll break something. If you're not breaking anything, then you're not learning.
Yeah,
so
trying.
That's how the whole purpose of what we're doing with Tech at Lunch is we want everybody to be able to learn, and maybe we even want it one day for this to be a CEU accredited podcast that you can listen to make sure that your certs are still intact.
Or web course based on if we have an academy or something like that.
Yeah.
Anything we can do to bring you in here and make y'all, be part of us.
Yeah.
If y'all listen to us, we definitely appreciate it.
I mean, 100% appreciate it. Like 100%. It's not. it's not easy to continue on without the support, right?
Yeah.
Like, if you've got no support, the only thing that's keeping us going is, like, the passion that we have. Now, we're going to keep going, but, like, the thing that Ed said is, if you're not breaking something, then you're probably not learning something, is I have so many parts, so many parts that are broken. But the thing is that I didn't let them stay broken. Like, it's wasted space if it stays there and it's not. You can repurpose it is the thing I'm going towards. So it's, if you can't find a way to reduce and reuse, then are you really helping with sustainability?
Yeah.
So
it's like we turn this into a lunch and learn for the ears. The good thing is, when I hear people say, hey, guess what, I listened to you. We got an idea from you. The folks out there and right now, I mean, we never thought that we'd be in certain parts of the world, and well, here we are. If you're listening to us in other parts of the world, hey, if you're, thank you. In the U.S., well, thank you too. Mm-hmm. We did some research and stuff like that on some stuff that's going on, but it's here nor there. I will say this: we did kind of some of y'all from Singapore. We did look up the NTU. The 3D printing capital of Singapore out there, and man, y'all are doing some crazy
technical
things.
University man. There.
Yeah,
is that titanium?
The titanium 3D print hip replacement. Yeah, mm-hmm. That's just awesome.
That's the whole point.
Right, and I know they do a speaker class and stuff like that. Who knows? Maybe one day we can make a trip out there and go sit down and just have a conversation. Mm-hmm. And never been to Singapore and
it'd be nice. Don't
think I'd turn down a flight. Even though I would be the one paying for it in my own pocket. But, maybe go out there and meet some people, talk about some certain things, still be
worth it, yeah.
Exactly. Still be fun. So from my side, I want to say thank you. And I'm going to turn over to the guys for the parting words, and we'll see y'all later.
Like I said, guys, we just appreciate all of the support. And from my side, like I said, I relish the challenge of teaching and helping people to learn, because I was self-taught in 90% of the stuff I did, as far as when it comes to IT, PCs, and OT, dealing with cybersecurity and things like that, and even IoT and IoT and MQTT. So if I can do it, anybody can do it.
Yeah. I just wanted to kind of touch on the ease of getting into this. It sounds, we talk high level a lot of the times. We're talking like end game, like a lot of heavy details that maybe not everyone has any experience in. But I think every journey starts with a single step. So you should just see if you can, get your hands on a printer or get around a 3D printer. And it's mesmerizing. I don't know. I've watched campfires before just because it's fire crackling, and I have watched prints because it's beautiful how it's moving. So the thing that I would say is try to get yourself around one if you're interested. Find a starting point, and then like Ed said, I love a challenge. I'm very competitive, so challenge us. Ask us to solve a problem for you. We'll see. We'll take a crack at it and try to involve 3D printing or some type of IoT.
Or tech of some sort.
Yeah, or tech of some sort. So yeah, once again, thanks guys. Greatly appreciate all the support.
All right, y'all. Have a good one. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.